Alright, welcome back. We're gonna do another simplex method problem, but hopefully I'm gonna try and get most things right. And the other warning is that this one, because I've worked through it already, is gonna have 3 simplex iterations, so it's probably gonna take us a while to work through, so you have been warned. Alright, so just putting up the I'm just putting up my just to make sure that I'm just gonna check my answers along the way just to make sure my working is right. Alright, so first things first. First things first is canonical form, and again we're starting with relatively simple exercise with a relatively simple exercise. So canonical form. So I'm gonna go jump straight into the tableau, and then hopefully you can follow the canonical form from there. So we've got 3 constraints this time. So got x1, x2, x3, s1, s2, s3, and then the right hand side that will behave itself. Alright, so that's gonna be 2x1 plus x2. Oh, I don't have an x3. Oh, excuse me. Well, that makes things a bit easier. And then so it's gonna be 1s1. It's gonna be 40, and then the basic variable is gonna be s1, s2, s3, and then there's gonna be 1, 1, and then that's 0. Sorry, I should put zeros there. 0, and then it's gonna be 30. S3, so it's gonna be 1 there. 0, and then 0, 0, 1, 15. And then I'm going to do the objective function. This is going to be the z row. So that's going to be minus 4x1, minus 3x2, and then that's going to be equal to 0. And then that's going to be zeros as well. So again, you can see in the this is much easier to see here, is that you've got an identity matrix, or just a matrix with ones down the diagonal, and so that's basically what we've come to expect. So first things first, the most negative reduced cost is -4, so we're going to do the ratio test. So just do ratio. Now, so that's going to be 40 divided by 2, so this 40 divided by 2, and then that's going to be equal to 20. And then there's going to be 30 divided by 1. That's going to be equal to 30. And then the last one is 15 divided by 1, which is equal to 15. So as a result, we're going to choose x1 to go in the basis, s3 out of the basic variable. Sorry. So that means, sorry, let me just write that out. So that means hold on, x1 in basic variables, S3 out. Okay, now, as I said before, we need to pivot. So thankfully, so let's rewrite the tableau. So we got basic variables, and I feel like I should just copy the tableau next time rather than having to rewrite everything out again. But since I'm going to be doing some calculations, it's probably not as feasible. So we're replacing s3 by x1, so I put x1 here, and then now notice that the x1 row already has a 1 here, so it means I don't need to divide. So I can actually copy over the row as is. So I'm just gonna do this. Oh, no, that's not straight. Unfortunately, my iPad's at an angle as well, so if you'll excuse me. So, okay, so that's going to be 1, 0, 0, 0, 1, x1, x2, s1, s2, s3, and then that's going to be the right-hand side. Okay, it just occurred to me that I probably should have used a grid paper system to kind of make this a bit easier, but it's a bit late for that now. Okay, so now what I want to do is that now I've got this pivot. I want to make every other number in that same column equal to 0. So I'm gonna make sure we do this correctly. So hopefully you can follow me there. So let's start with the bottom row first. So that's gonna be so in this case row 4, which is equal to row 4 plus 4 row 3. Alright, so what's going to happen is that we've got the z here, and then so we're going to have 1, that's going to be 4 times that, plus minus 4, so that's going to be 0. There's 0 here, so the minus 3 remains the same. The zeros, 0 again, and then that's going to be plus 4. So it's 4 plus 0. Okay, and then that's going to be 15. 15 plus 4. Sorry, 15 times 4. That's going to be 60. And then we've got the 0 done. Now we need to subtract from the other rows. So let's do that again. So let's row 2 is equal to row 2 minus row 3. So that's going to be 1. So that's going to be this one minus 1. So that's going to be 0 up here. We're going to have the 1 minus 0. So that's still going to be 1. Pardon me. There's still going to be 1 there. 0 minus 0. That's going to be 0. 1 minus 0. That's going to be 1. And then 0 minus 1. That's going to be minus 1. And then we've got 30 minus 15. So that's going to be 15. Okay. Now for the first row, it's going to be row 1 equals row 1 minus 2 row 2. Because we've got a 1 here, we've got a 2 here. So we need to subtract we need to subtract from row 1 2 times the new row 3. So thankfully this one is relatively easy to figure out because there's not as many annoying numbers. So go let me okay. So 2 minus 2 times that, so that's going to be 0. So what? And then we've got 1 minus 2 times 0. So that's going to be 1. 1 minus 2 times 0. So that's still going to be 1. 0, 0 is still going to be 0. And then 0 minus 2 times 1 is going to be minus 2. And then you've got 40 minus 2 times 15. That's going to be 10. So it's going to be 40 minus 2 times 15, 40 minus 30, which is going to be equal to 10. Okay, so now we've got the tablet at the end of the first iteration, and it turns out that we still have a negative reduced cost. So now we're going to need to do the ratio test again. So I'm kind of going to do it a bit more condensed. So do the ratio test here. Some people might prefer to write out another tableau. That's fine as well. So we're going to do a ratio test here. So in this case, it's going to be 10 divided by 1. So it's 10 divided by 1. And also notice that this is going to be x2 that's going to be going into the basic variables. And then here we've got 15 divided by 1. So that's going to be 10. That's going to be 15. So now the lowest ratio is the one with S2. So as a result, what's happening is that x2 is... Oh, sorry. So x2 in, S2 out. Okay, so now once again we need to pivot. We've done the ratio test. We need to pivot on x2. So fingers crossed the calculation is not as bad this time. So s1. Now we're replacing s2 by x2, and then we've got x1 down at the bottom, and then we've got z at the bottom of the bottom, I guess. And then x1, x2, s1, s2, s3, right hand side. Okay, there we go. Now we want to pivot on x2. What a pivot on this is already a 1. We don't need to do any division, so I can copy out the row as is. So that's going to be 0, 1, 0, 1 minus 1, 15. And then now I want to make every other number in that column every other number in that same column equal to 0. So let's deal with the 0 again. Let's deal with the 0 again. Get rid of that minus 3. So, and that's going to be the hardest calculation. So that's going to be row 4 equals row 4 plus 3 row 2. Okay, so let's see if I can do this. So 0 plus 3 times 0, that's going to be 0. Minus 3 plus 3 times 1, so that's going to be 0 as expected. And then 0 plus 0 is going to be 0. 0 plus 3 times 1, so that's going to be a 3 here. And then that's going to be 4 plus minus 3, so that's going to be 1. Oh, So that's going to be 1 over there. And then we've got 60 plus 3 times 15. So that's 60 plus 45. That's going to be equal to 105. Oh, we're getting there slowly. I have a feeling I've done something wrong. So I'm just kind of slowly checking slowly checking my calculations. 10, 15, 15. And then we've got 10 and 15 by the ratio. And then I've got 3. It looks like I've got a problem somewhere. Oh, I'm so sorry. Turns out I picked the wrong result of the ratio test. I'm so sorry. So the ratio test, I should have picked this one. I should have picked S1. So it's going to be S1 out. And then, so let's clean things up a bit. So that's not going to be X2. Not going to be that. Not going to be that. So once again, the simplex method is very easy to get wrong by hand, which is why we have computers to do all our work for us. So, okay, so S1, hold on. So now, so we want X2 here, and then we want S2 here. So in a similar vein, so once again, we've got the 1, we've got the, pardon me, we've got the 0, we've got the 1 up here. That's the one we want to pivot on. 1, 0, minus 2. Right hand side is 10. And then we've got, now I want to do, let's just subtract down the rows this time. Doesn't really matter which way you do it. So it's going to be row 2 is equal to row 2 minus row 1. So subtracting down. So 1, so 0 and 0 is 0. 1 minus 1 is going to be 0. 0 minus 1 is going to be minus 1. 1 minus 0 is going to be 0. Minus 1 minus 2 is going to be positive 1. And 15 minus 10 is going to be 5. Okay, we're on the right track. And then since this one is already a 0, we don't actually need to do any calculations. So 0, 0, 1, 15, and then we still need to do the 0. So the 0 is going to be row 4 equals row 4 plus 3 row 1. Alright, so the zeros is going to be 0. So first column is going to be the zeros. The minus 3 plus 3 times 1 is going to be 0. Alright, so 0 plus 3 times 1 is going to be 3. 0 plus 0 is going to be 0. 4 plus 3 times minus 2 is going to be minus 2. Oh, if only we could wrap it up there and then. So, and then we got 60 plus 3 times 10, so that's going to be 90. So that's our next iteration of the simplex method. Unfortunately, we still have another reduced cost, so which we need to deal with. So, oh boy, thankfully I know this is going to be the last one. So I'll kind of bash through it, I guess. Maybe saying less, if you can follow me from there. So now, so by the ratio test, we have 10 divided by minus 2, which is minus 5. So it's a negative. It's a negative, so we don't, and it's a negative, and we only want positive ratios, so we don't need to worry about that. So, and then, alright, the other ratios, we've got 5 divided by 1, so 5 divided by 1, and then the last one is 15 divided by 1, so that's equal to 5, that's equal to 15. So our lowest ratio is the 5 here, which means that S2 is going to be the variable coming out, and S3 is the variable coming in. So, so let's write this down. So S3 in, S2 out. Alright, so now let's do the table again. BV, and then there's X1, X2, S1, S2, S3, and then the right hand side, and then there's going to be X2, S3, X1, and then the 0. Alright, so now I want to pivot on, S3, so we've got a 1 here, that means the 1 can stay. So what does that mean? So that means we can copy out the row as is. So that's going to be 0, 0, minus 1, 0, 1, and then 5. And then we want to make like before, every other number in the column 0. Oh, we have to do all the rows. Okay, row 1 equals row 1 plus 2 row 2. So that's going to be 0. That's going to be plus. Okay, so 5. So that's going to be 20. So and then no, sorry, I should work from the forward. So 0 plus 0 is 0, and then row 1 plus 2 row 2. So 1 plus 2 times 0 is still going to be 1. That's going to be minus 1, and then that's going to be 0. Okay. And then we've got, and then for the third row, for the x1 row, we need to adjust that as well. So this is gonna be a 1. So sorry, I should write out the row operation. So row 3 equals row 3 minus row 2, because we want this one to be 0. Okay, so we've got so row 3 minus row 2. So 1 minus 0 is 0. 0 minus 0 is 0. 0 minus 1 is 1. 0 minus 0 is 0, 1 minus 1 is 0, and then 15 minus 5 is 10. And then we've got to do the z row as well, so that's going to be, we've got a minus 2 there, so it's going to be row 4 equals row 4 plus 2 row 2, because we want that minus 2 to be a 0. Alright. 0, 0, it's going to be add 2, so that's going to be 3 minus 2, so 3 times 2, 3 plus 2 times minus 1, and that's going to be 0, and then it's going to be 0, and then there's going to be 90 plus 10, 90 plus 5, 2 times 5, so that's going to be 100. Alrighty, so, and now we have no more negative reduced costs in our z row. They're all 0 or positive, which means we are done. So I'm kind of just checking the timer, and good god, this took me 17 minutes. Alright, so our optimal solution is x1, x2, s1, s2, s3 is equal to... Now, in this case, the basic variables is x1, x2, and s3, which means those are the ones that will have numbers. The ones without numbers do not have any values at all. So x1 is equal to 10, x2 is equal to 20, s1 is equal to 0, s2 is equal to 0, s3 is equal to 5, with a z value of 100. Alrighty, so... yeah, that's that, and we are done. So, Simplex method, really annoying to work out by hand, and this is the part where it's more like, okay, we're just gonna let computers do our work. So, don't hesitate to kind of just Google like online Simplex method solver and get it to do the working for you, because it's very easy to make silly arithmetic mistakes, and that's totally fine. So that's the Simplex method. We will develop more on this in future videos, where where like, you know, we might need to adjust it for different situations and things like that. So until then.